Definition of an ellipse. An ellipse is the set of all points xy, the sum of whose distances from two distinct fixed points, which are called foci, is constant. See figure 4.22. And if we look at figure 4.22, we see that you have two fixed points here, focus 1 and focus 2, which are two foci, and you have distance 1 and distance 2, and the point xy, which represents all the points on the ellipse. Distance 1 plus distance 2 is a constant. The sum of the distance from the point to focus 1 and the distance from the point to focus 2 is equal to a constant. So if I pick another point here on this ellipse, which is over here, if I take this distance here and this distance here and add them together, I would get the same number that I got up here when I added these two distances together. So any point that I choose, if I measure those two distances and add them together, I would get the exact same number that I got here. So that's the definition for the ellipse. Now here we show the center of the ellipse. In the examples that we'll be looking at, the center of the ellipse will be at the origin. You have the major axis, which is the longest axis, and the minor axis, which is the shorter axis. And then you have the vertices. You have four different vertices for the ellipse. Now on the major axis we have what we call the foci. So one foci would be about here, and the other foci would be about, one focus would be about here, and the other focus would be about there. Okay, this shows how you can take a string and you can use two nails for your fixed points and attach a string to the nail and then put the pencil in the nail, and just you can draw the ellipse by doing that. Now here we have the standard equations for an ellipse whose center is at the origin. These are the standard equations when the center is at the origin. Now in this case, A is the major, the radius of the major axis, and B is the radius of the minor axis. So that's why we have 0 is less than B is less than A. This means that both A and B are positive number and that B is shorter than A. So you have two forms of the standard equation, as you can see there. X squared over A squared plus Y squared over B squared equals 1. Now in this case, the longer axis is under X squared because A represents the radius of the major axis. So A goes from the center to the point on the ellipse along the major axis. And B is the shorter axis. So in this case, the major axis would be on the x-axis. The major axis would be along the x-axis. So the one that A is under, or A squared is under, that's the major axis, and the one that B is under is the minor axis. So Y would be the minor axis here. Now in this case, the A is under the Y squared. So in this case, the longer axis would be along the y-axis, and the shorter axis would be along the x-axis. Now notice that for standard form you have to get 1 on the right side of the equation. If you're trying to write an ellipse in standard form, you have to get 1 on the right side of the equation. And on both equations here you have positives on both of these terms here, positive The x squared is a positive and the y squared is a positive, so they both are positive. Now here we have some examples showing the different parts of the ellipse and the relationship between those parts. Now in this case, the a squared is under x squared. So that means that the major axis and the major radius is on the x-axis. So as you can see here, the longer axis is on the x-axis. So the larger number, if the larger number is under x squared, then the major axis would be along the x-axis. If the larger number is under y squared, here's the a squared is under y squared in this case. So in each case, the a represents the longer radius, or the major radius. So here you will have the larger number under the y squared. So the longer axis would be along the y-axis. Now if you look at this, you can see the label for the focus. The focus, you have the points negative C0 for this focus if you're along the x-axis, and you have C0 for this focus if you are along the x-axis. In the vertices, you have A0 because the distance from the center to this point here is the major radius. That's A, this distance here. So if this distance here is A, this point would have to be A0 because you don't go up or down any to get to this point. So Y would be 0. For this point back here, this vertex, the coordinates are negative A0. For this vertex, this radius here, this minor radius is B. The distance from the center to a point on the ellipse along the minor axis is the minor radius. So essentially, an ellipse is a circle with two different radii. Now, this vertex here is 0, negative B. Now there's a relationship between the focus, which would be C, the x coordinate of the focus, or the y coordinate of the focus, and A and B. And that relationship is C squared equals A squared minus B squared. This is how you find the coordinates for the focus. You can find C, and once you get C, you know that one focus would be C0, the other focus would be negative C0 if the larger number is under the x squared. If the larger number is under the y squared, then the focus, or the foci are always on the major axis. It's always on the major axis. So the one that's the longer one, that's the one that would contain the foci. So you would still use the same formula to find the coordinates of the focus. C squared equals A squared minus B squared. So that formula there can be used at any time to find the focus, or the foci. Okay, let's look at an example so that we can see how this process works. Example 3 here on page 365, finding the standard equation of an ellipse. Find the standard form of the equation of the ellipse that has a major axis of length 6. So that's the length of the major axis. So the major axis, half of that length would give you the major radius. So if the major axis is 6, that means that the major radius would be 3. So the major radius is always represented by A in the standard form for the ellipse. So we already have the value for A. We know that A is equal to 3. Now, the foci, we have the foci given here. The foci at negative 2, 0, and 2, 0. So those are the two foci as shown in figure 4.25. So figure 4.25 show this figure. And we can see that where the foci are, negative 2, 0, and 2, 0. And we can see that the major radius is 1, 2, 3 units long. and if you go to the left, it's 1, 2, 3. The major radius is 3 units long. So what we have to do in order to write the equation, you have to know both A and B. So it said find the standard form of the equation. So all we have to do now is find B, because we know that A is equal to 3. Since the major axis is 6 units long, the major radius A is half of that, which is 3. So we just use the formula that we had over here. The formula is c squared equals a squared minus b squared. We already know what c is. In this case, if you look at the figure here, c would be equal to 2, because the foci, you have negative c, 0, and c0 for the foci. If the major axis is on the x-axis. So we use that formula, and we can find b. So if we solve the formula for b squared, we get b squared equals a squared minus c squared. Just take the same formula that we had here, and to solve this for b squared, we would subtract a squared from both sides, and that would give us c squared minus a squared equals negative b squared, and then multiply both sides by negative 1, and that would give us negative c squared plus a squared equals b squared, and then just switch the c squared and the a squared around, negative c squared and a squared around, and that will give us the formula that we have here. So we just substitute into this formula here, and for a we substitute 3, so we have 3 squared minus c is 2, 2 squared, 3 squared is 9, 2 squared is 4, 9 minus 4 is equal to 5. That means that b squared is equal to 5. So really we need to find the value for b in order to be exactly in standard form. Now the author here writes the problem as x squared over 9 plus y squared over 5 equals 1. So you have x squared over a squared. So you have x squared over a squared plus y squared over b squared equals 1. And we said a is 3, so that means that this would be x squared over 3 squared, x squared over 3 squared plus y squared. Okay, b squared is equal to 5. So if we have b squared equals 5, to solve for b, all we have to do is take the square root of both sides, and that would give us b equals the square root of 5. So technically we would have y squared over the square root of 5 squared equals 1. So this is technically, the formula would look like this, but since the author does it like this, I will accept it like this also. Let's go back and recap here what we did. If you know the foci and the major axis, then if you take half of the major axis, that would give you the major radius, which is A. And if you know that the foci are negative 2, 0, and 2, 0, that means that C is equal to 2. So if you know those two things, you can use the formula c squared equals a squared minus b squared in order to find the value for b. And once you find the value for b, you just substitute those values into the standard form, x squared over a squared plus y squared over b squared equals 1. So in this case, we really technically have x squared over 3 squared plus y squared over the square root of 5 squared equals 1. So then that would be the equation of the ellipse in standard form, technically speaking, but as I said, this form would be acceptable also.